Hi everyone, happy Monday. I hope you're doing well. Hopefully you had a good weekend, and I'm hoping you're not super stressed by um, following the numbers of the infections for the coronavirus, and I'm hoping you're trying to sort of distract yourself from that. I'm going to do a quick example using the ratio test. I know you just watched the video from Khan Academy. I want to make sure that everyone's comfortable with what this means, a over a sub n plus 1. So let's say if your sequence is, I'm going to make something up, 2 to the n over n plus 3. And if you want to find a of n, a sub n plus 1, then that would be equivalent to 2 raised to the n plus 1 power. And here it would just turn into n plus 4. Okay, and that's not the example that I wanted to do. So I want to do an example with you. And so here's a series that they want us to find if it diverges or converges. And it's 1 over 2 times n, the quantity factorial, from n equals 1 to infinity. Want to make sure that we're working with positive terms, and this series that I just wrote is going to produce just positive values. And so here is my limit as n approaches infinity. My numerator is going to be 1 over 2 times n plus 1, and then the entire thing is under factorial, divided by a sub n is the original. It's 1 over the quantity 2n factorial. And obviously next time you can skip that step because division is the same thing as multiplying by the reciprocal. So here's that. I'm going to distribute this 2 right here, so it's 2n plus, actually I'm not going to distribute it, I'm going to leave it. I'm just going to leave it the way it is, n plus 1, and the entire thing is under the factorial. Okay, so my numerator is just 2 over 2 times n. This is my numerator. And we need to figure out what answer we get when I evaluate this limit. And here are the 3 cases. All right, so the numerator, right, if we look at 5 factorial, that's just 5 times 4 times 3 times 2 times 1. So the numerator is 2 times n times 2 times n minus 1 times 2 times n minus 2 times 2 times n minus 3, and so on. That's what the numerator is showing. The denominator is showing it's the quantity 2 times n plus 1 times 2 times, I'm going to take away 1 from here, so it's just 2n times 2 times n minus 1, and so on. And I'm hoping you sort of catch the drift what's going to happen with the numerator and denominator. These are all going to cancel. So I'm just left with the limit as n approaches infinity of 1 over 2 times n plus 1. I know that is going to approach 0. And then if my limit answer is less than 1, then the answer for this is it converges. Okay, one more thing I want to talk about, the ratio test. So the ratio test, don't be surprised if you can apply L'Hopital's rule. So when we're evaluating these limits right here, right? So all of this is evaluating at a limit. I didn't need to use L'Hopital's rule because a lot of, in this part right here, a lot canceled. So I did not need to use L'Hopital's rule. And I know when we're doing sequences, I said you can't use L'Hopital's rule for sequences. So sequences are discrete, they're not continuous, and you can't use L'Hopital's rule. But series, right? If we're going to plot a series, think about what we're plotting. We're plotting the partial sums. The partial sums are continuous. So when you're looking at series and you're working with limits, when you're working with series, you can, as long as you get an indeterminate form, and as long as you get infinity over infinity or 0 over 0, for series, you're allowed to use L'Hopital's rule. All right, before I go on to my next topic, I wanted to talk about the AP exam. I'm sure you've heard that you're going to have a 45-minute exam, and there's not much that they shared right now for AP Calc. April 3rd is when they'll share more information. Again, I know that so I'm looking at AP Calc BC right here. We'll talk about the units that are not included. So this unit 9, I'm looking at the the third column. This unit 9 is obviously not corresponding to our textbook. It corresponds to the units in AP Classroom, so if you want to take a look, you can. But I will share really quickly what unit 9 is. Well, unit 9 is chapter 11 for us. So we're on chapter 10 at the moment. So nothing from chapter 11 is going to be on it. Again, if you're looking at the screen with me, it's the third column that shows that the topics are not included. The second column shows the topics that are included. So chapter 11 is not included. And then from chapter 10, so Taylor's series is included. Lagrange's upper bounds are not included. So I'm hoping you're happy with that. And a few of the tests are included and a few are not. So for example, the nth term test is not going to be on the exam. The integral test is not going to be on the exam. And the direct comparison tests that we did, the direct comparison test and the limit comparison test, they're not going to be on the AP exam. So the other thing that all we know is it says, so looking at this part that's bolded, there'll be a 45-minute online free response exam at home. So even though, well, that's not what I wanted to do. Even though for AP Calc, like these asterisks show, we don't know when you can take the exam, and then the first asterisk is for the exam questions and the type. And then the second and the third, the last two columns are for date 1 and date 2. And for AP Calc BC, it's all unknown. So April 3rd is when you'll find out the 2 dates that you can take the exam. And then I don't know if this is what we're expecting. The bold says 45 minutes of free response questions. So I'm going to assume that there are no multiple choice on the BC exam. And again, I'm just going to wait, and we're all just going to wait till April 3rd. Okay, thank you for listening. I'm going to go on to my next topic. And so our next topic has to do with about working with series that produce some negative values. So the ratio test, the direct comparison test, the integral test, and the limit comparison test, they only work when your series is positive for the values that you're working with for n. There's a way around that, and here's how there's a way around it. So we are going to be discussing, or I'm going to be discussing, the difference between something converging or series converging absolutely versus it converging conditionally. So we've got 2 types of convergence: absolute convergence, or we have conditional convergent. There is a theorem on page 510 that says if you are looking at the absolute value of a series, and if the absolute value of the series converges, then a sub n also converges. So that is the theorem, and I want you to write this down, please. That's the theorem that's on page 510 of your textbook. I'm going to do a quick example to use this theorem. It's that example from, and I'll just go back. I'm looking at number 3. It's this example. I'm hoping you checked my answer key, and how in this example we couldn't use the direct comparison test because that series was not always positive. Now there's a way around it. So that problem that I just showed you, we're going to take the absolute value. So here's what was given. It was cosine, and I forgot what it said. It was cosine of n over n. That's what it was. Let me remind ourselves. Nope, 2 to the n. And so we know that this is going to produce negative values and positive values, but let's look at the absolute value of this. You know, the absolute value is going to take anything that's below the x-axis and reflect it up. So if you look at the graph of cosine of n, you know it oscillates from positive 1 to negative 1, but if we take the absolute value, it's always positive. And so now we can compare the absolute value to 1 over 2 to the n. So they are, this part, 1 over 2 to the n, is greater than or equal to, and we know that this converges because it's a geometric series due to the geometric series test. So this converges. Therefore, so the higher one converges, it pushes down. Therefore, that converges. And now, so I'm using the direct comparison test to say that the one that's higher converges, so the one that's lower also converges. And now I'm going to use this theorem to say, well, if the absolute value converges, so does what the original problem was, right? Without the absolute value. This was the original problem. And again, it's this problem right here. Without the absolute value, that was number 3. So this also converges. Okay, really quickly. I used the direct comparison test right here. This was the direct comparison test. Once I came up with the inequality, and then if this converges, then that converges. And then I use this new theorem that has a title. It's absolute convergence implies convergence, but the title's a lot to say. Based on that, we have that this converges. Okay, so this is what it takes if something's, if the absolute value is converging, then this converges also. Now I'm going to talk about the difference between absolute convergence and conditional convergence. So where you want to look at, there's a definition on page 510. And the definition says if this series, again the absolute value, if this series converges, then we're looking at just this series of a sub n without the absolute value, then that converges absolutely. Then this series converges absolutely. So let's talk about the difference between absolute convergence versus conditional convergence. And so before we do that, I want to talk about what happens if this diverges. So this is the definition on page 510. And the rest of the information that I'm going to say is not on page 510. So if this diverges, because that can happen, if this diverges, but if you evaluated the series without the absolute value bar, that converged or converges. Therefore, this series is conditionally convergent. Or converges conditionally. That's more common. So this is the difference between absolute convergence and conditional convergence. So let me do a quick example to show you this whole thing about conditionally convergent. And I promise to do a little more about that once we introduce some more tests to evaluate if a series is converging or diverging. So here is -1 raised to the n plus 1 power. You know what the -1 raised to the n plus power n plus 1 will do? The signs will alternate, right? It'll be positive, negative over n, and as n approaches 1 to infinity, right? If I plug in n is 1, my first sign is positive, but if I plug in n is 2, my second sign is negative. So it's an alternating sign series. Let's take a look at the absolute value of this series. So the absolute value of this series, actually I don't have to write that out, we can just talk about it. The absolute value of this series, the numerator, if I take the absolute value of the numerator, it's only going to but it's only going to produce positive values for like -1 raised to n plus 1. If I take the absolute value, it's only positive values. I'm sorry, that took a long time to say. So if I take a look at the absolute value of this, the absolute value of that is just 1 over n. As n approaches 1, and I lost the infinity symbol. So now we know this is a harmonic series. The harmonic series diverges. We know that. So the absolute value of this, and we're looking at this right here. This, the absolute value diverges. And now here's where you might seem a little confused. Well, let's look at the series without the absolute value. What about -1 raised to the n plus 1 power? And this is the part that we haven't really done a lot because there's no test right now that's going to work for a series that produces negative values. So once we learn, it's actually called the alternate series test. And right, I talked about the signs alternate, and the test is called alternate series test, which is not what I'm teaching in this video. The purpose of bringing up this test is once you learn this test, you'll see that without the absolute value, this converges. So the absolute value of this series diverges, but the original series that was given converges. So your final answer is, if you look at, because this was what the question was, that was the original question. The final answer is it converges conditionally. That's the final answer. And then when do you need to address if it's conditionally convergent or absolutely convergent? The questions in the textbook will see that. So I thought I had it bookmarked. Give me a second. I'm on 10.5. And it says, like here, determine whether the series converges absolutely, converges conditionally, or diverges. Tonight, I'm not going to give you any of those homework problems because we need to learn the alternate series test. All right, guys, so sorry for making such a long video. I will talk to you later. Have a good day.